calculator. The first thing we're going to do is type all this into a table on our calculator. Notice it says 1950, just do 50. So you ignore the fact that this is all in the 1900s. So main menu, we need stat. And you need to type in all of that data. So 50, 60, 70, 80, I already typed in. And then 631, 824, 1079, 1430. Type in all the data. So to figure out if it's linear or quadratic or exponential, you need to have the calculator do all of those for you. So we are calculating the regression line, so go calc regression. Linear is x, so pick x first. And then I prefer the ax plus b because it looks like mx plus b. The same, but it doesn't really matter. So here's our ax plus b, but what we need to look at right now is that r squared value, 0.986. So let's go back right here. For linear, r squared is 0.986. To determine which regression we're going to do, linear, quadratic, or exponential, we got to check the r squared values. The higher r squared value, the better. Do the same thing now, but we're going to run quadratic. So back it up. Quadratic is x squared, so we're going to pick x squared. So same thing, we're going regression, calculate regression, x squared. Now notice our r squared value is 0.999. It's pretty good. The closer to 1, the better. And then we're going to check exponential also, so same thing, just back it up. We need exponential, so it's not here. Scroll over, exponential, exp. And we'll do the ab to the x, 0.998. So compare your r squareds, 0.986, 0.999, and 0.998. The closer to 1, the better. So quadratic is the best. So that's what it contains, quadratic data, because it's really, 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 really close to 1. Write an equation to represent the data. That comes from the calculator. So go back. Since we just said it was quadratic, go back to our quadratic so we can write down the equation. Ax squared plus bx plus c. So it's 0.277 squared plus bx. So minus 9.98 x plus c. So plus 431.77. So there's your equation representing the data. And we're going to use that equation to make a projection for the world grain production in 1998. So we're going to use that equation and plug in 98 for x. So the easiest way to do that is to copy if that's an option. If not, you have to retype all of those decimals. But if you've got copy as an option, go ahead and copy it. And we're going to paste it. You got to push exe to paste into y1. Now that we copied and pasted, you go main menu, you go to the graph. Now, if you just try to draw it right now, it's going to give you an error because right now the equation is not selected. you have to select it first. Make sure you select it. There's a little box to show that it's been turned on. Now you can draw it. We don't see anything because our window doesn't fit the data. Our data, the X values go from 50 up to like 100. Since we care about 1998, we got to make sure that we include 98. So if we go 50 to 100 for our X values, that'll be good. So change our viewing window from 50 to 100. Zeros. 50 to 100. You can change the Y values also because they go up to like 2,000 something. Looking at the data, it goes up to 1769, so I would extend that a little bit further. That way, when you draw it, now you can actually see the curve. Alternatively, you could select table. Make sure it's selected there. And then we want to know for 1998, which means an X value of 98. So type in 98, and it will give you it. If you're doing it from the graph, you just do a gsolve ycalc and type in 1998, or just 98 because you ignore the 19s. 2115. Table or graph, either one's going to give it to you. Doesn't really matter. 2015 or 2115.4. So the last thing to make sure you include is units. You need to include the units. So this is million tons of grain. Million tons